Right, good morning, pilot teachers and students. Good morning, class. Okay, thank you. You may sit down. Right. Lesson 11, we went through the straight line graphs, and we have already looked at straight line graphs. And in this lesson, we'll be basically going through and looking at the slope or the gradient. Right. What is the slope or gradient of a graph? Marvin. All right. Pass it. Okay, what is the slope or gradient of a graph? Okay, switch on that. Sit on. All right, he is giving us the explanation of the slope, how you can find the slope, and that is the rise over the run. Okay, that is quite correct, but my question is, what can you tell about a slope? Or what is the slope of a graph? Kimberly, what is the slope of a graph? It is the okay, what is your explanation again? It is the tilt of the graph. All right, okay. When you are going through those graphs, looking at those two graphs, you find that there is a constant. So the slope is simply the constant of proportionality. Okay. So in this lesson, we'll be basically going through and then looking at the gradient or the slope of the graph. Right. That definition gives you the. Okay, that is the definition of the slope. The slope or gradient of the graph equals to straight line graph, and that is the constant of proportionality, right? And it is given by this equation as slope equals to rise over the run, or y over the x. Right, quickly have that one done. I will go through, give you another slide or two more slides, and then I will go through my explanation, and after that I will give you the activity. All right, good. Most of you are almost finished. I will now give you the next. Okay, you finished? Okay, now to the next. Okay. All right, before you go through copying this information, let me explain to you this graph. Right, for example, you are given the values for y and also the values for x. Right, you simply know this is the dependent variable, so it has to run on the vertical axis, and that one is the independent, right, meaning that it is the cause of what is happening. All right, you plot the points, and that you have the points which up here, all right, for the first one, which is 1 for the x, and then you have the 2 for the y, and so on. Right, finally, you found that the graph runs from the origin, which is 0. Right, to calculate, or in order for us to calculate the slope, we are given this formula or the equation, which is given as rise over the run. Rise is simply this one, the y, and the run is simply the x-axis. Right, looking at the values, we can simply calculate the slope at any point, whether it is set between 2, which is for x, and 4, which is for y, or we can simply take the whole, which is 6 and 3, and then calculate the slope. For instance, you are given 6, that is 6 minus 0, that is the rise, and then you have run, which is 3 minus 0, okay, because it starts from the origin. That is why we have 6 over 3, and that gives us 2. And that 2 is the gradient or the slope, or it is simply the constant of proportionality. Right, quickly have this one done. I'll give you an activity later. Okay, now to our activity. I'll give you two activities. The first one, you'll be given a graph and also the quantities, right? Okay, I have explained the first one already, but just quickly go through and then I will give you the activity later on. Okay, the slope or gradient of the straight line graph equals the constant of proportionality. All right, for a straight line graph, you're given slope equals to rise over the run, which is equals to y over x. Okay, that is. Okay, again, that is the graph that you have copied earlier. Give here the rise and also the run. In this case, the slope that you calculated was 2. Right? Simply, it is the constant of proportionality. And now to the activity part. Right? Quickly have this one down, or you can simply look at this, and then I'll give you the questions that will follow. After that, there is also activity number 2 in which I will give you, and for that one, you can graph the results. And there is a chart that is on the board. I will be asking students to come up and then do that activity and also the explanation. Okay, the craft papers are coming around. Make sure you do that activity. On these craft papers and then paste them nicely into your books. 3, 4, 1. Okay, quickly have that table done. I will give you the questions as follows. Right now to the questions. I'll give you the questions. Right, the first question is to calculate the slope between time equals 2 seconds and 6 seconds. Question number 2 or B will be, what does the slope tell you of in the first 2 seconds? And third question is, what does the slope tell you between 2 seconds and 6 seconds period? Right, using the graph that you have drawn, you can now answer the questions that follows. Okay. Write down those questions quickly. I will give you activity number 2 so that you can plot that on the graph paper that I just gave you. Okay, activity 2. Okay, by now you should have finished writing down those questions. Now on to activity number 2. Quickly use those graph papers to plot these results. Right, quickly plot that and then come up with an equation. Finish. Calculate the slope between time equals 2 seconds and 6 seconds. What does it tell you in the first second? What does the graph tell you in the first second, and what does it tell you, or what does the slope tell you in this between 2 and 6 seconds? This one. Okay. What does the slope tell you in the first 2 seconds? For this one, first 2 seconds. What does it tell you between 2 and 6 second period? Yeah. First, calculate the slope. 2 seconds, only for 2 seconds. for you go for the last question. This one. Can you do this question? Okay. Question. Activity 1A. Activity 1A. And activity number 1B. You go for number 2. And okay. Activity 1C. Graph these results. You graph the results and then you quickly come up with an equation. Okay, P equals to something plus where the intercept is, y-intercept is. Okay. A. B. Activity 1B. And activity 1C. Okay, let me have a look at those students who just went through and then complete your graphs. Okay. It's okay, just plot in those points. I finished with those. Okay, continue that quickly. How do you plan to use that graph? Okay, if you have to weigh which is the dependent and which is independent, looking at P, you can run P over here. Yeah. Yeah. P is the P equals. Okay, how do you plan? Okay, which one of those P, and then W should be, yeah. Yours is C. Okay, what does it tell you? If the slope is this way, then you look at the variables. What does the variable? It is X and Y, is it? So at this point, distance against time. Distance against time give you the speed, so that means speed will be, which in here it will be, if you find a more steeper curve, what does that tell you? Speed will be okay. When you are doing that extension, you know that this is distance against time. So a steeper graph shows you that the speed is okay. It is high, and when you have a slope that is less, that means the speed is less slow. Okay. So at which point do you think this speed will be high? Yeah, because it is a steep slope. Okay, when you plot this, the P will be running up this way, is it?
You get this way?
Okay. And then
P is the vertical axis and W is the
W is the okay, x-axis. Okay, you're given this one. This is not time and distance. Okay, time over distance gives you the speed because of distance over time. So, what does it tell you? If you were given something like this in a much more steeper graph, what does or slope? What does it tell you? Speed is high. Okay, fast speed it is, but in here it is low because you have a more graph that is leaning that way. Okay, we will now go through the correction of those. For the first activity, we will not use this one, but probably using those graph and also the information given on the first activity, you can now go through and then explain those. Right? There are 3 questions basically given to you: question A, B, C, and A, B, and C. And for the second activity, probably we will be using the graph that is already on the board for our explanation. All right. First question. Okay, first question. Soren. Okay, come up. Okay. I'll pass you the mic and then you can explain. Okay. Here. Here. Okay, you explain your. Sorry. You explain your. Okay, let's have a look at the first one. She has this information given to us. Okay. Okay, for activity number 1, let's have a look at her answer. All right, in the first 2 seconds, what is the slope? All right, simply the slope equals to Kimberly, what is the formula used in calculating the slope? It is the rise over the run. So simply, the rise is simply okay, 10 minus 0 in the first 2 seconds. That is 10 minus 0 divided by 2 minus 0. So our answer is 5. 5 is the constant of proportionality, or simply the constant or the slope at that point. And for question number 2, she has done that also, and that is the slope at 6 seconds. All right, if it is at 4 seconds, let's calculate the slope. All right, in here at 6 seconds will be 6 minus 2. 6 minus 2 would be 4. And 15 minus 10 would be 5. So you have 1.25. 1.25 is the slope at that point at 6 seconds, or between 2 and 6 seconds. All right, good. That is all right. On to question number 2, or question B. Okay, John. Okay, you said using that you can come. Probably you can use that too.
So what does the slope from 0 to 2 seconds tell us about the graph? Because it's the slope is more steeper. Because the slope is more steeper, that means the speed is high. So that's my answer for question 2.
Okay, very good. Okay, the next. Okay, use that. You can explain that as well. Use the mic.
The slope from here to there is not very steep, so it shows that the speed decreased. The speed decreased because it is from it's not steeper than this one.
All right, may I help? You've seen the working out already. The first one is 5 and the second one is 2. All right, in here you find that it is 2, so 2 is the highest number. So that means the speed will be high because we have distance over time. Speed equals to distance over time. So the graph of distance over time will give us the speed. At this point, you have a slope which is large. Okay, from our calculation, it is 5. So that means the speed is high. And at this point, it is about 1.2, and that is why we have a slope that is going that way. That shows that speed is quite low, right? Now to the last activity, and that is only okay. Sulaiman, you can use that to plot quickly. And then your explanation. The other one is power. Then you have W, which is going on that. Probably this one is dependent. W should be the independent. Okay, piece is dependent. That is why it is running on the vertical axis. Okay, through the line. You can through the line.
When I graph the results, I end up with a straight line. So the general equation is what y is equals to mx plus c, which is the y-intercept. Okay, p, because I got the p as my dependent variable, p is outside, and w is the independent one, so it's inside the gradient. This is actually the gradient, and the gradient is worked out by the rise over the run. And as you can see, I worked it out, I got 0.0373 recurring. And this is the gradient, plus c, which is the y-intercept. As you can see, if I draw a line through this, from these points to the 0, it will pass to the point of origin. So that's the question.
Okay, from using this graph, we can now draw a line. Okay, let's say a line of best fit. Right, using that line, after plotting these 2 points, we can come up with the gradient or the slope. Right, when you're going through, in our last lessons, you know that you know how to come up with the equation for the graph. Right, the first, so in this case, probably you can use p equals to, right, a gradient plus, okay, calculating the gradient or the slope times this variable that is plus the y-intercept. Okay, so that is how you can come up with the equation for this after you have plotted in the graphs for p against w. Right, those are the points here, and then you can throw in a line of best fit, and where this one comes in is simply the y-intercept. And having that equation, or working out the equation for this, can be p equals to slope times this variable plus a y-intercept. Okay, so that is how you can come up with a graph or the formula that is relating to p and w. Right, anyway, you can go in your own time and then go through this information again. Use those graphs to plot a graph properly. Probably use another graph paper, and then you will be able to come up with the equations. Probably you can bring it to me for, okay, so that we can check. Now for pilot teachers and students, if the pilot students are going through this information as well, they can always plot a graph and then bring it to you so that you can check the equation. But anyway, the graph for this would be something like p equals to 0.3 w plus, okay, 3.5, because it runs straight into 3.5, which is the vertical axis on the p. Okay, good. That brings us to the end of our lesson. Our keyword for today is slope or the gradient. Okay, once again, good morning, pilot teachers and students. Good morning, class. All right, thank you. You may sit down.